Welcome back to Math with Miss Reimer. Today Stanley's gotten himself stuck in the sea of bubble wrap. Today we are looking at extension section 6f-3. So this is a special episode of Math with Miss Reimer. We're looking at rationalizing the denominator. Rationalizing the denominator just means we're trying to get the radical out of the denominator. So to do that, we're going to multiply by some form of 1. The easiest form of 1 to use is what's already in the denominator. So for example, when we look at problem 1, in our denominator is the square root of 7. If I multiply this entire fraction by the square root of 7 over square root of 7. Now the key here is the square root of 7 over square root of 7 actually just simplifies down to 1. But because we're using the square root of 7 form, it's going to enable us to get rid of the radical on the bottom. So when I multiply across, I end up with 5 square root of 7 over the square root of 7 times the square root of 7 gives me the square root of 49, which simplifies just to 7. And then 5 square root of 7 is left on top. What this did is it got the radical out of the denominator of the fraction, which for this section is our goal. In number 2, we're going to do the same thing. We're going to multiply by some form of 1, and so we're going to pick whatever is in the denominator to multiply by that, because square root of 6 over square root of 6 equals 1, but when we put it that way, it will get rid of the square root on the bottom here. Multiply across the top, we get 7 square root of 6 over the square root of 36, which simplifies just down to 6. The quotient property of radical simply says when you have a fraction under the radical, it's the same as if you split the radical into 2 pieces. So for example, if you have the square root of 16 over 25, you can split the radical into 2 pieces, and that's how you just get 4/5. So in number 3, we're first going to split the radical into 2 pieces. So we get the square root of 2 over the square root of 3b. And now I'm going to try to rationalize the denominator. I'm going to multiply by square root of 3b over square root of 3b, because this is equivalent to 1, but it will allow us to get rid of our denominator on the bottom. We know from the multiplication property of radicals that I can multiply anything that is under the radical together. So the 2 times 3 will give me 6b, and on the bottom we get the square root of 9b squared. When I simplify some more, the square root of 6b is as simplest as it gets. But the bottom, the square root of 9 is 3, and the square root of b squared is just b by itself. Remember, when you take the square root of something squared, they cancel out. This now is your final answer because we got rid of the radical on the bottom. In number 4, I'm going to start by splitting this radical into 2 pieces. So the square root of 5 over the square root of 48. I'm going to multiply by the denominator, so we'll take square root of 48 over square root of 48. When we do 5 times 48 on the top, we get 240. And on the bottom, when we do 48 squared, we get 2,304. 240 I can split into the square root of 16 and the square root of 15. And on the bottom, our square root of 2,304 gets back down to 48. Square root of 16 on the top is 4 over square root of 15. And 4 over 48, both of these are divisible by 4. So when I do 48 divided by 4, I get 12 on the bottom. So we're left with the square root of 15 over 12. In number 5, once I split my root into 2 pieces, I need to rationalize the denominator, so I'm going to multiply by a form of 1. That will cancel the bottom. So we're going to use that square root of 3n cubed over square root of 3n cubed. Multiply through, and we will get 24n cubed on the top. And on the bottom, we'll get 9n to the 6th. Remember, we'll add those 2 exponents. 24, I can simplify down into 4 and 6, and then an n squared and an n. And on the bottom, we'll get back down to 3n cubed. On the top, when I simplify, my 4, square root of 4 comes out to 2. Square root of n squared comes out to n. The 6n is still stuck underneath the radical, and 3n cubed is still on the bottom. And when we get here, we can simplify one step farther. With our n's, we have a n to the cubed and then just an n here, so I can subtract. So I will end up with 2 6n in the square root over 3n squared. And that's all for today.